bank which is introducing a savings account, which is paying interest on the account balance. Now, the question we had, according to that, this savings account class was a child of current account, and we were asked what is the problem with this class. Now, we corrected this to make it something like this, where we have an abstract class called bank account.
But what is the problem with it? What's the problem with the original one?
Current account and savings account, they cannot share all their functionalities. Savings account will not have all functionalities of current account. They might come from a common class called bank account, which will have different types of accounts, but the different types of accounts may not be sharing each other's functionalities or properties or that reason.
Like the more easier example would be like a rectangle and a square. Like if a square is a child of a rectangle class, it doesn't need height and width. It just needs one parameter because the height and width is same for square. So suppose if rectangle has two methods like set width and set height, and if a square inherits them, so it doesn't need both of them. It will be the same for the square.
Basically, they can come under a common class called shape, but you don't necessarily need to derive one from the other. So it works in a similar way for this. And we were supposed to talk about what design principle is transgressed.
Alright, it's Liskov substitution principle, as I said about the rectangle class and the square class. Since apparent, so the saving accounts cannot use the withdraw. It can use the withdraw amount, but there will be some significant errors which the saving accounts will face.
Okay, you got the right idea. Does anybody know the example that he's referring to, rectangle and square? No one knows that example? Okay, a rectangle has four sides. All of the sides are perpendicular to each other. And a square has four sides, and they're all perpendicular to each other. Now, is a square a child of a rectangle?
Yes.
Yes. So it's actually a bad example to use. But the idea here is that you've got these two accounts, and they would have probably different properties. They sort of like when you use that example, it was kind of the right idea, but the difference here is that when you're looking at current account and savings account, it really depends on the bank as to how they would administer the withdrawals, how they would administer the interest and stuff like that. So if you were to come to one bank with this model, and they said, well, yeah, but we have a withdrawal of $500, it means the savings account can withdraw $500 too. But that might not work because maybe the savings account, you have to have a minimum balance of $1,000 in the savings account, which is you're not able to put that in with the present withdraw method. So you would have to override that withdraw method right away. And then with the interest, are you saying current account doesn't have interest?
It has different value of interest, as in interest would be much lower for current than for savings.
Yeah, but in the model it's not even there, so it appears that you don't have any interest with current account. So the way that it's set up is obviously not very supportable. Okay, so that's the lesson here, is that when you're doing classes, first of all, you've got to decide what its properties and operations are, and then you've got to decide whether these things are common with other classes. If they are common with other classes, then you can do this idea where you can do a pull-up. But if they're not common with other classes, then how do you organize them? Well, one way is to organize them as a set of accounts against an abstract parent. Okay, that's the key. This parent is abstract, which means it's not necessarily providing methods downwards. Those methods are not implemented. And remember, that was extension by abstract. If you remember on the object design, extension by abstract. Okay? So that's what you do. You look at this and you decide how the two classes relate to each other based upon the principles you've seen here. Self-describing, self-updating. Okay? So be careful that example is actually a bad example. Because it is a child. It is actually a child. And it works. But it works because there's no change in the principle between a square and a rectangle. That you never have a square that has anything other than all four sides the same. That is the definition of it. It won't change, but this will change. This will depend on the bank. Okay, good. Let's look at the model over here, the